My name is Tengku Ahmad Syafi, and today I'm going to talk about the differential length, surface, and volume of the Cartesian, cylindrical, and spherical coordinates. First off, we're going to start with the Cartesian coordinates, the differential length of the Cartesian coordinates. Now, the differential length of Cartesian will use the coordinates of x, y, and z. For differential length of A, we will get the magnitude of dx because it is on the x-axis, and the direction of ax because it is pointing towards the direction of the x-axis. For B, the differential length, the magnitude will be dy because it is on the y-axis. The unit vector A will be ay because it is pointing towards the coordinates ay. For C, here we will get the differential length of dz az. dz, the magnitude dz because it is on the z-axis, and the unit vector az because it is pointing towards the z-axis. For D, here D, we will get the total of A, B, and C, that is dx ax plus dy ay plus dz az. It is because it is pointing towards this, from the origin to this point here. So we will have to take the displacement that is from here, from the origin to the differential length of A, to the differential length of B, and to the differential length of C. Same goes when we go to this direction, from origin to differential length of B, to the differential length of A, to the differential length of C. Why am I saying this is the differential length of A and this is the differential length of B? Because this direction is parallel to A, so it is in the same direction and the same magnitude, because that's why I'm also calling this ax, the differential length of A, and that's why I'm calling this the differential length of B, because it is parallel together and at the same length. Next, we'll cover up the differential surface. Now, in the differential surface, we will cover up three surfaces, that is dsx, dsy, and dsz. For the differential surface of x, we can refer back to the differential length, that is dy dz ax. Now we can get this from the differential surface of x. Now we can refer all this in the differential length. Actually, for a surface, we can, to get this surface, multiply this length and this length. This length is actually the differential length of y. This is the differential length of z. That's why we can get this two magnitudes. We only take the magnitudes from the differential length because this surface is pointing towards the x-axis, so therefore the direction, the unit vector is ax. Next is the differential surface of y. The differential surface of y is the same with the differential of x, the same concept as the differential surface of x. Actually, we multiply with the differential length of this and this, and we get dx times dz. Now this is the magnitude. You can see that this length is the differential length of x. It's parallel together here and here. We know that this is the differential length of z because it is parallel together here and here. And the unit vector will be ay because the surface is pointing towards the y-axis. Lastly, the differential length of z. The same concept is x and y. We will get the magnitude, we will get dx times dy because we times the length here, differential length here, and the differential length here. This is x, this is y, and the unit vector will be az because it's pointing towards the z-axis. Next, the differential volume. And we know that this is the differential length of z. Up here is the differential length of y. Here is the differential length of x. So we just use the usual formula for calculating the volume of a cube, that is length times width times height. Only the different thing is that we write this in terms of vector. It will be dv, the differential of volume, equals to dx times dy times dz. Now we actually can get this formula back from this by triple integrating the right hand side of this and integrating the left hand side. When integrating these three, we will get x, y, and z. Therefore, this one is the same as this. Next, we'll cover up the cylindrical coordinates. And for the cylindrical coordinates, the points we are using are rho, phi, and z. The rho represents the radius of the cylinder, which is here. And the phi represents the angle, the azimuth angle of the cylinder. And z represents the height. Now, so that's done, we should move on to differential length. And for the differential length of A, we can see that it is pointing in the direction of rho. So, the differential length will equals to d rho A rho. And for the differential length of B, you can see that it is pointing with the phi. It's pointing at the same direction as phi. So, differential length of B will be rho d phi A phi. For the differential length of C, you can see that it is pointing towards point Z. Therefore, differential length will be dz a z. Now that is the differential length. For the differential surface, we can refer back to these differential length to create a differential surface. For example, this surface at the back of this cylinder, I will call this A prime. Now for A prime, for this surface, you will get a differential surface of d rho dz A phi. We will get this differential surface because of the d rho is here and dz is here, and the unit vector A phi is because it is the surface here is pointing with the azimuth angle here. It's pointing with the same direction as the azimuth angle, so it will have a unit vector of A phi. Now, for this surface, call this B prime. For B prime, you can actually tell that the differential surface is pointing towards rho. So the unit vector should be rho, A rho. Now the magnitude should be rho d phi dz. Because it is the rho is here, the phi is here, and dz is here. So we should take that magnitude besides A rho. Now for this surface, call it C prime. For C prime, the differential surface, you can tell that the unit vector is pointing towards I'm sorry, this is not should be, it should be here, up here. This is C prime. Now that surface, now you can see that this surface is pointing towards Z, so we can tell that the unit vector is AZ. Then the magnitude, we can tell that it is a combination of rho and phi. Rho and phi beside Z. So from the differential length, we can take the magnitude rho and the magnitude of phi. So we write back, it will be rho d phi, rho d phi. Now that is the differential surface. Now for the differential volume, you can tell that it is rho d phi d rho d rho d phi dz. Now this is the differential volume. From this differential volume, we can actually get the volume of the cylinder if we integrate both of the sides here. This just single integrated. On the right side, we triple integrate it. So when we integrate it, we should get integrate this, we should get over 2. So if we integrate this, we should get phi 2 pi 0. Integrate this 1, we should get Z. Now we submit this in. Should get this, and this will be, should cancel this up, will be pi r square, yes, pi rho square Z, or the real cylindrical volume of cylindrical, for the formula for calculating the volume of cylinder is pi r square h. You can see that this and this is the same. The rho is the radius, the z is the height. So we can see that it is the same. Now that's a cylindrical coordinates. Now let's move on to the spherical coordinates. Now for the spherical coordinates, the points we use is r, theta, and phi. The r represents the radius of the sphere. The theta represents this angle, the latitude angle of the sphere, and the phi is the usual azimuth angle. Now, move on to the differential length of the sphere. Now for differential length of A, you can tell that the differential length is pointing towards or with the r radius. So the magnitude should be the r, and the unit vector be ar, because it is pointing towards the radius. The differential length of r can be here, 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 anywhere, here, 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 or here, because it's a radius. Now for the differential length of B here, we can see that it is in the direction of theta, so the unit vector is obviously a theta. Then the magnitude should be the magnitude of d theta, so it will be r d theta. Now for differential length of C, we can see that it is in the direction of phi, therefore the unit vector is phi. Now the magnitude the magnitude should be respect to the theta, so it is it's respect to phi, so the magnitude is r sine theta d phi, a phi. Alright, now that is the differential length of a sphere. Now for the differential surface of a spherical coordinates, for example, we can use this surface up here. Now this surface, we can see that it is pointing towards radius r. Therefore, the differential surface is the surface is pointing to r. Therefore, the unit vector should be ar. Now the magnitude, we can take that the magnitude that has no relation with ar. So we take r d theta and r sine theta, and then we can get r d theta times r sine theta d phi. We simplify it, we can get r square sine theta d theta d phi ar. Now for the differential length, for the differential length for the differential surface of this side, this is a theta, b theta. And for b theta, we can get, and we can see that the direction of the surface is pointing with the azimuth angle. Therefore, the unit vector should be a phi. Now the magnitude should have no relation with a phi. Therefore, we can take the magnitude of r. It has no relation with phi. That's why. So we can take the magnitude of r and theta. So it should be r d theta dr. Now for this, at this bottom surface, C prime, it's actually pointing towards theta. So the direction, the unit vector should be a theta. So the magnitude should have no relations with theta. So we can take dr and r sin theta d phi. We write down, we should get r sin theta d phi dr. Now if the surface pointing down, the E should be negative. The surface pointing up should be positive. Now for the next, for the differential volume, we should get all these combination, that is r sin theta d phi times r d theta times dr. If we can get r square sin theta dr d phi d theta. Now actually we can get the formula for the volume of sphere of a sphere, that is 4 over 3 pi r cube. We should get this from this by integrating both sides. We should integrate this first. We should get r cube over 3. Oh, sorry, the range should be 0 to r. This should be 0 to pi. 0 to 2 pi. Now it is 0 to 2 pi here. 0 to 2 pi. 0 to here only. So it should be here 0 to r, and this integrate sign, we should get negative cos theta. This should get phi 2 pi 0. This we should get cube over 3 pi, right? Pi negative cos 0 should be 2 pi over 3. After calculating this, we should get 2 pi. Now we should get 4 pi cube over 3. See, should get the same as this. Now that is all for